Hi guys, we are going to finish up our lesson 7. We had 2 more questions in class, well, 1.5 questions on this, so I wanted to finish it up. And then the lesson that you're actually going to do today is lesson 8, special case inequalities, and there's only like 4 problems. So I want you to turn to, again, we're at lesson 7, question 5. And do you remember this one where we talked about the president? And it says that he speaks for 10,000 people, and it's the actual crowd would be 750 more or 750 less. So if I put 10,000 on this, why is this not writing? Wow. What's going on here that my thing's not writing? What is going on? There we go. Okay. I think it just had a little hiccup there somewhere. Okay, let's try that again. So if I have 10,000, let me redo the whole thing. If I have 10,000 people, and I say that it's going to be, the crowd could be 10,000, but approximately like 750 more or less, then I would add the 750, right? So it would be 10,750, or I would subtract the 750, and it would be 9,250, right? And it says the actual crowd could be more or less that. Then how we're going to look at it is it's actually anything that could be that or this or in between. So even though it comes out like it kind of seems like it's an or problem, where like ors we said are like going in opposite directions, this actually is an and. So how I would write it is like that. Okay. For 6, take a minute and read this one. I'm not reading it for you. You read it. Take a minute. Okay. So it says between. So when I think between, I'm going to think a low end and a high end, which actually ends up to be an and statement. So we're going to go anywhere from 25 miles each week to 30. Now, that's over a week's time. And it says, what's the range of miles that she should walk each day? So I'm going to say, let D equal days. So if we think about that, we know that there's 5 days in a week. That's how we're referring to this one. We're not counting like the weekends. We don't exercise on weekends. So you're going to do 5 Ds. So the 5, oh, you know what? We should have said this. Not D. Not D for days, my bad, is M for the miles. The miles you should walk each day. Totally my bad. Sorry about that. So the miles that she's going to walk in each day. And we know she's going to do 5 days. So we would do each day times how many miles, like overall, like per day you're going to go. Okay, so this is miles per day. Let's be more specific. Are you with me on that now? Not days. We know it's 5 days. What our unknown is the miles per day. Okay, so I know I've got to be in this range. So look what I did. I said 5 times M, and it could be anything greater than 25 or anything less than 30, but not including. And then I'm going to solve just like we did in class. And 30 divided by 5 is 6. So what we're saying is that for each day that we walk of those 5 days, we're going to walk anywhere between 5 miles and 6 to get that average, to get that 25 in a day, or a week, and 30 in a week. Okay? All right. So let me move my head here. Get to the next page. Okay, this is a fast one. Real fast. we got something called special cases, okay? So what we talked about with compound inequalities is we always said that the compound inequalities are going to go, like if it's an and, it's going to be like towards each other. So the and statements, like we just did, would be anything like that. And the or would be going in opposite directions, whether the dot is closed or open or closed, depending on whether it includes it or not. So those are the traditional situations, but there are special cases. Okay, so there are going to be some scenarios where it seems like they should go in opposite directions, but they actually go in the same direction. Okay, so let's talk about those. And remember, or means one or the other, and means it must satisfy both. Okay, and that's key. All right, so let's start with this one. It says, for the following inequalities, solve and graph. So if I were to solve for this one, or solve for the second one, okay, I'm doing it kind of fast. You know that you would add the 6, right? And you would get -6 and then divide by 3 and you get -2. So I'm doing the algebra real fast for you. I'm trying to make it short for you guys. Now, when I look at this on a number line, remember -5 is here and -2 is here. So let's start with -5. All right, I'm going to do this one in green. So it says x is anything greater than -5. That seems like it might be going in the wrong direction, right? And then here it says x is anything greater than -2. Open, right? At -2. Still going in the same direction. So this is an or statement. So or means it can satisfy one or the other or both, right? So what I'm going to do is I'm actually going to look at it on the number line and go, well, then that means that I can say we start at -5, we don't include -5, and we go to infinity forever. And the reason why we go to infinity forever is because I can include -2 in this green one, right? Because remember the green one, let me make it actually a little bit thicker. The green one is that, right? And the green one saying that we can have any x that's greater than -5 includes -2. So even though -2 is not included in the second inequality, it's included in the first. So it's anything greater than -5. So that's a special case scenario. All right, so let's try another one. Take a minute and solve 2 here for me. Solve for x for both of them. I'm going to let you do it this time. Solve for x. You should have gotten x is greater than 4, or x is less than or equal to 6. Okay, so let's do these let's color coordinate them on a number line for us. So let's start with the green one. Let's go a little bit thicker. And we're going to say, okay, I got 4 here. And this says x is greater than 4. So that means I've got everything that goes greater than 4. Or I've got 6 here. And it includes it, right? Now notice right away that the green line, that inequality is going right through 6. This one says x is anything less than or equal to 6. Look at that. That goes in the opposite direction, and it covers the 4. 4 is not covered in the green, but it's covered in the red. Okay? So that to me looks like, and it's an or, so it can be one or the other. It doesn't have to be both. So that to me says I've got every number in the real number system that will satisfy one or the other or both. And the both is where they overlap, obviously, right? Okay, so there's another special case scenario. All right, let's do it again. Solve for these two. These are ands now. Solve for the 2 ands. I'm going to give you a minute and solve for the 2 ands. Solve for both, 3 and 4. And if you're not, if you're still solving, pause it. And I'm going to pop them up here. All right, so hopefully you've got yours solved. I'm going to start with this one, where it says x is greater than -3. So if I got a number that where x is greater than -3, I've got to go to the right. Now let me do this one, where x is less than -20. Now the key thing here is it says the word and. And means, remember, it's got to satisfy both inequalities. Now, they didn't do it as like a compound like this. If they come over to the side, they didn't do one of these. They didn't do one of those, right? They literally separated them and said solve them separate and then put them together as an and statement. I can't put those together as an and statement, can I? I don't have the green and the red on the graph, on the number line, do not overlap. So in this case, I have a no solution because I have to have numbers that satisfy both because it says the word and. So there's no solution. Special case. Okay, let's graph this one. Red. X is greater than -3/4. And this says x is greater than -3. Okay, so again, it's an and. I have to see where they overlap. All right, so I can tell right now, this piece right here, there is no overlap, which means that that section from -3 to -3/4 only satisfies one inequality. I have to have numbers that satisfy both inequalities. So they start to overlap right after -3/4. Not including -3/4, because -3/4 only works for the green, but not the red. Okay, it only satisfies the green, but not the red. Okay, so because of that, our answer is going to be x is anything greater than -3/4. Oh, geez, -3/4. So when we do it in an interval notation, we're going to do -3/4 to infinity. Okay, so this is what's going to happen. I've got more answer keys going up for you, Honors Crew, in this homework, this Unit 2 homework answers in Content Library. So look for them. They're going to go up sometime today, which is Wednesday right now, because we're Wednesday morning. So I will pop them up. So do your homework and then check them. All right, and make sure that you're getting it, you're on track. And then for the rest of the week, cohort A, you're going to be doing your review and then your checkpoint. Thursday, Friday. Cohort B, you're going to do the same, but it's going to be on Tuesday, Wednesday. Okay? All right, guys, take care. See you soon.